All right, today we're going to be continuing dealing with measuring angles and arcs. All right, does anybody have any problems on the front page that we're not able to... Yes, sir, go ahead.
15.
Number 15. All right, we're going to take a look at problem number 15, except I'm going to zoom in on this guy right here. So hold on. Take a look at 15. Going to take a screenshot. And clear. Go over here. Take a screenshot. Now we can go back and forth. All right, here we go. Now, problem number 15 says we need to find the arc, the length of our... By the way, don't try to say that really fast. People might get upset.
Oh.
You get it?
Yes, I know.
No, I won't say it. That would be awkward. All right? So, by the way, what are we trying to find? We're trying to find the arc length of P to S to R. Not going to say it out loud. All right? So, just remember, you chose this. Yeah.
Push her.
Hold on, let me pause it. Real quick. All right, if this makes you need to go to the restroom, I apologize. So right now, we need to find that arc length. Does anybody know the formula for arc length?
Yeah.
Somewhere. Go ahead.
Degree of the arc.
Circumference, you're right, times the
Degree of
the arc.
Divided by 360.
Wow. Bless you, bless you, bless you, bless you. So right now, that formula would be 2 times pi times r times the degree that we are searching for out of 360 degrees. Now, by the way, we know our radius. What is it equal to? How many units? That's right, 13.5. Thank you, Kale, for saving the day. So 13.5 is going to get plugged in right there. All right. Now all we need to find is the what? Bless you. Not the bless you. We're going to find the degree. Now, it says angle PZR, all right, is equal to what? 150. Let's look at it. I've got a P, I've got a Z, and I've got an R. Let's go ahead and make that angle right now. Let's see here. Let's make it a little bit thicker so you can see it. Going from P to Z to R. So how many degrees is that angle? 150. Now we're trying to find from what? P to... Oh, man. Can you guys see the Pac-Man? Can you see Pac-Man?
Yeah.
All right? See Pac-Man? We need to know the measure of this arc, not this arc. So we need this whole thing. Right here, I'm shading it in. Well, hey, when he's hungry and he's chasing a ghost, you'd be surprised. All right. So, right now, let's put a little eye right there. Okay? Let's give her some teeth.
Yeah.
All right. I know. It's amazing why I'm just not an artist.
Why did you not become an artist like Van Gogh instead of like becoming a teacher?
Well, let's put it this way. Nobody's going to buy this stuff. Okay?
Nobody wants to buy.
Nobody wants to buy a ginormous-looking Pac-Man with teeth. So right now, well, you know what? There you go. You know what you can do. So by the way, how many degrees is this, everybody? How many? 210. That's right. Because if this right here is 150, that's 150. One of those suckers have to add up together. So by the way, go back here. We were just able to figure out a very important piece of the information. What are you plugging in there? Not 150, you're plugging in 2. All right, so here you go. Go to your graphic calculator. Here we go. Type in a 2. Type in a 5. My favorite's Apple Blackberry. Feel free to give me. That's out of 5. Love it. Apple Blackberry. Right. Very difficult to find. My dad and I's favorite pie. Then we're going to type in 2 Apple Blackberry. Yes. It's delicious, especially with Bluebell homemade ice cream on it. Oh, yeah. All of that is typed in correctly. What do you do now? You just press. And voila. You have your answer. I know. Sometimes, it's hard to stay in the same voice for long periods of time. It's hard to stay. But you know what? We'll just keep going as long as we can until I peter out. All right? So right now, what's your final answer?
You say Peter just alone?
Well, that would be one of the famous apostles, Peter. Also, there's also a very famous group called Peter, Paul, and Mary.
I was thinking of
I was
the
saying
Peter that was
Mark.
associated with
All right. So, by the way, does anybody have any other questions on page 1?
Wait, what was it?
Really? You're asking me. You're gonna. How about this? Just go back.
Oh, yeah.
There you go. It's not that difficult.
number 17.
Number 17. By the way, how many degrees are in a circle? 360. Now, if I wanted to find 8%,
360 divided by 100 times 8.
let's do it a little bit easier. How about this? How about we take 360, multiply it by the decimal equivalent of 8%. That's all you got to do. Do 360 times the decimal equivalent of 29%. That's all you got to do. Here we go, right? Here we go. 360 times 0.08, which is 8% as a decimal. What do you get? 28.8. Now, I asked you on this particular problem to round it to the nearest degree. So we're going to write 29. Go back here. Do the next one. If you, hopefully you'll see the pattern. That says 104.4. Notice, I'm not going to round this one up. Why? Because that's a 4. It's not a 5 or higher. So we just keep it the same. Keep what the same? 104. You don't round it down. You just keep it the same. All right? By the way, does anybody know what we call any arc less than 180? Or how about this? What do we call an arc greater than 180? We call that guy major. Let me tell you something right now. You got 360, you multiply it by 0.58, which is 58%. You'll realize, ooh, that's bigger than 180. That's 209. So, of these, which is the only one that is a major arc? The only one is 2 to 3 hours. That's it. All the other arcs are going to be what? What are these percentages all going to add up to? 100. What are all these degrees going to add up to? There you go.
Wait, so what are we going to do for...
All right, how about this? Let me zoom out. Help you out. Here we go. We're zooming out. A little too much. We'll zoom back in. All right.
Wait. Oh.
There we go. So it says for exercise 17 and 18, refer to this table. It says if you were to construct a circle graph of data, how many degrees would be allotted to each category? This is the answer to number 17.
Oh, okay.
Answer. Now, describe the arcs associated with each category. Are they major or minor? Did you notice how I was labeling them? If I see you label, I give you credit. No label, no credit.
Alright, so those are minor for one,
Got minor, major.
major.
Talk to the hand. I mean, just see the hand. Don't talk to them. All right. By the way, all we're going to do right now is we're going to do problem number. We're not going to do 19 because that's Michi's problem. It's really easy. So we're going to let you guys do number 19. All right. But we're going to do problem number 20. All right. Problem number 20 says use a ruler to measure the radius of the circle. By the way, I've already used a ruler on this, so I'm going to let you guys know. Some of you may have gotten 2.9 centimeters. Some of you may have gotten 3 centimeters. So we have to figure out which one is going to be the closest to X to Y to Z.
I'll say that real quick.
X, Y, Z. There you go. X, Y, Z. It's okay. You can say this fast.
This is a joke.
Oh.
We don't want to say
All right. By the way, What you're going to do right now is you're going to find the arc length of x to y to z, which goes from x, y, all the way to z. Now, if this arc right here is 75 degrees, how many degrees is all the way around? You're right. 285 degrees, which I know you're about to say 360 minus 75, so you're still right. So right now, that's what you need to use. So here's what you're going to do. You're going to do 2 pi r. You can either use a 3, or you can use a 2.9, so you can use a 3. And you're going to multiply it by 285 out of 3/6. We're going to find an approximate value for that step. All right? Plug that in. Let's see what we get. All right, so what's the approximate value for the arc length if you typed it into your calculator? Go ahead.
14.9.
14.9. Now, one thing you notice. What did you notice?
It's not up there.
It's not up there. But then, wait a second. You saw something else. What did you see?
Oh, it's boxed up right there. Closest.
Closest. So which one would you say is the
16.
By the way, sometimes the answer is not going to be perfectly up there. When they ask you to do what? When they ask you to measure. When they're asking you to measure something, the exact answer may not be up there. Okay, so you got to find the closest. By the way, what does problem number 19 deal with? The same exact stuff. So what formula are you going to use for number 19? This formula. What formula are you going to use for number 21? That same formula. What are you trying to find? You're trying to find the length of what? The approximate what? Arc length, which is right here. Can everybody see the portion of the circle for problem number 21? Anybody have a problem seeing the circle? Everybody sees the circle?
Yeah.
You do?
Yeah.
There it is.
Yeah.
Yeah. See what I'm saying? That's an arc length of the circle. So I'm not helping you with 21. Alex, could you read number 22 for us, please?
Alex loves listening to old cassette tapes and finding out.
Right on, man.
A diagram of a power volume control knob on the stereo shown below.
All right. Keep reading. You're doing good. Just living on a prayer right now. Keep going.
When the stereo is turned on and the knob is turned to a volume level of 5, the knob is rotated 100 degrees from its off position.
All right. Here's what I want you to write down first. Everybody write this down. The volume. When volume is equal to 5, knob's rotated 100 degrees. Write that down. 5 goes to 100. Write it down. Do it. Live it. Know it. Love it. Let's go.
Do it.
Do it.
Do it.
All right. Keep reading.
What is the approximate arc length of the path traveled by the knob's rotation from the off position to the volume level of 10?
Ooh, good thing you read that whole thing. Because some students might accidentally use what? 100. But we're going to what volume? 10. That's right. The reason why I raised my voice is I was raising the volume. You're right. I like how you think there. See how that happened? Went from 5 to 110 to 200. So what are you going to use in your formula? 200, not 100. So which formula are you going to use? Circumference equals 2 times 5 times r times, we're going to put 200 out of 360. All right? But I'm not going to tell you what the length of the radius is. That would just be wrong. You should be able to figure out just from looking at the problem what the length of the radius is. Good luck.